now let's look at the multiplication rule. So anytime you're going to use a multiplication rule is because you have an and probability. So probability of A and then B, that's the same thing as saying the probability of event A occurring in the first trial and then event B occurring in the second trial. Remember, in an OR probability, we also had the probability of A and B. The difference between these two is that this one is a single trial. This one is more than one trial. Okay. We also need to ask, are these events independent or dependent? Whereas in an OR probability, so OR probability, we had the addition rule, and we ask, is it disjoint or not, or mutually exclusive or not? In an AND probability, we use the multiplication rule, and we ask, are these two events independent or not? So if they are independent, you just multiply the two probabilities together. If they are dependent, then you have conditional probability. So what this says is probability of A and then times the probability of B given that A has already occurred, because A and B are dependent on each other. They affect one another. Whereas the probability of A and B here, if they're independent, they don't affect one another. Okay, we have two different types of sampling. One with replacement, which is always code word for independent, and without replacing, which is always code word for dependent. Now, a card is chosen at random from a deck of 52 cards. It is then replaced, and a second card is chosen. What's the probability of choosing a jack and then an 8? Okay, then replace. So we know by definition this is independent. So we're just looking at the probability of a jack times the probability of an 8. Where there are 4 jacks within 52 cards, and there are 4 8s within 52 cards. So this will give us 16 over 2,704, which if you want to see it as a decimal, that's the same thing as 0.006. Or it's like saying you have a 0.6 chance of reaching in and getting 2 cards, the first one being jack and the second one being an 8. Or another way of saying is, if you do that action, drawing 2 cards, if you do that action 2,704 times, then only 16 of those 2,704 times will you get a jack and then an 8. Now say I need 2 students to help me with a stat product demonstration for a class of 18 girls and 12 boys. I choose one student, then I choose a second student. What's the probability of selecting 2 girls? Okay, well, if I've got a classroom of students and I choose one girl, I'll go ahead and choose the first girl. I'm not going to put her back into the drawing pot because I might select her again and then I'm only ending up with one girl for my demonstration. So once I choose that first girl, I'm going to not put her back into the drawing pot and I will select a different girl. So that's saying that this is without replacement. If it's without replacement, then this is going to be dependent. So the probability of choosing girl 1 and then girl 2 will be the probability of choosing girl 1 times the probability of choosing girl 2, given that I have already chosen girl 1. Okay, the probability of choosing girl 1 will be, I've got 18 girls out of, 18 plus 12, that's going to give me 30. Okay, so I've chosen the first girl. I'm not going to put her back into the drawing pot. She's going to be set aside. And I'm going to go in and choose another one. So I don't have 18 girls left. I have 17. I don't have 30 students left. I have 29. So multiply these two together, you get 306 over 870, which will reduce down to 51 over 145. And that will be your final answer. Okay. Say you've got a jar contains 3 red, 5 green, 2 blue, 6 yellow marbles. A marble is chosen from the jar, then a second marble is chosen. Number 1, what's the probability of choosing a green and then a yellow? And 2, should there be a red flag about this question? Well, I guess since I'm asking that, there probably is. So it says right here, a marble is chosen from a jar and then a second marble is chosen. Well, what did you do with the first marble? Did you put it back in the jar or did you throw it at your friend? So let's look at both of them. So with replacement and without replacement. So with replacement, we know that is independent. So if we're looking at the probability of green and then yellow, we're just going to multiply these two together. Okay, we've got 5 green out of 16 marbles. The 3 plus 5 plus the 2 plus the 6 is 16. Times, okay, I've got 6 yellow out of 16. So that's going to give me 30 over 256, which is 15 over 128. Okay, if we compare that without replacement, so that is dependent. So now the probability of green and then yellow will be the probability of green times the probability of yellow, given that we've already taken a green out. So probability of green will be 5 over 16. Probability of yellow, given that we've taken a green marble out and didn't put it back in, will be 6 over, not 16, but 15. Okay, so now this is going to be 30 over 240, which will reduce down to 1 over 8. Okay, now notice here, for the independent side, this bottom number right here did not change. It stayed exactly the same. And that's how it's going to be with independent events. The bottom number is going to stay the same because nothing's affecting it. Whereas independent or dependent events, the bottom number will get smaller and smaller and smaller. Also notice that the first event is exactly the same, because in independent, well, there's nothing to affect it. In dependent, the first event isn't affected by anything. It's only the second event that's affected by the first event. Now, with that being said, we do have one exception to the rule. So, say you have a nationwide survey found that 72% of people in the US like pizza. If 3 people are selected at random, what is the probability that all 3 like pizza? So these 3 people are selected from nationwide. They can be from anywhere. New York, say one from New York, one from California, and one from Louisiana. Okay, and we're just basing their opinions, and we're going to share that with the whole world. Okay, so the three opinions of those 3 people, that's going to represent the entire nation. Okay, so when a small number of items are selected from a large population, like 3 people from nationwide, without replacement, because I wouldn't go to the same person and say, do you like pizza? And then turn back to that same person and say, well, do you like pizza? And do that again a 3rd time. Do you like pizza? Because the person is going to give the same answer 3 times. We're going to ask one person, take them out of the selecting pot and go to someone else. So this would be without replacement. Okay. The probability of each event changes so slightly that the amount of change doesn't really matter. So technically, because it's without replacement, this should be dependent. But what we're going to do is treat it as though it was independent from each other, because the differences between independent versus dependent probabilities don't differ very much when you have a super small amount of items taken from a huge population. So we go with using the independent formulas over the dependent formulas because they're a little bit easier. So if we're trying to find the probability of getting someone who likes pizza, and then who likes pizza, and then who likes pizza, If I treat it as though this was independent, I'm just going to multiply all these together. Well, the probability of someone liking pizza, 72%, take it out of a percentage, multiply this 3 times, which on your calculator this would be easier, raise it to 3, and this would be the same thing as 0.37. But that's the only exception to the rule. Say you've got a shipment of 20 computers, 3 are defective. 3 computers are randomly selected to test. What's the probability that all 3 are defective if the first and second ones are not replaced? So not replaced, we've got dependent events. So probability of getting a defective, and then defective, and then defective. Okay. Well, they say 3 out of 20. So I have 3 defective computers to choose from out of 20. Say I get that defective computer, I set it aside. Now I have 2 defective out of 19 computers. I take that computer, set it aside. Now I have 1 computer that's defective out of 18. Multiply all this together, you get 6 over 6,840, which will reduce down to 1 over 1,140. That would be your final answer right there. If on a test you had 2 questions, true, false, and a multiple choice with 5 options, what's the probability of getting both of them correct? Okay, well, one question doesn't affect the other, so the probability of getting both correct, that's the probability of getting the true, false correct times the probability of getting the multiple choice correct. The probability of getting a true, false is there's 1 correct answer out of 2. The multiple choice with 5 options, there's 1 correct out of 5. So this would be 1 over 10. Flipping a coin and rolling a die. What's the probability of getting a heads and then a 4? Heads and then a 4. Since these two don't affect each other, they're independent from each other. Because I flipped a coin and got a heads doesn't mean that I'm going to roll a die and get a 4. So that means this is probability of heads times the probability of rolling a 4. Probability of getting heads is 1 head out of 2, heads or tails. Rolling a die, if it's a 6-sided die, 1 out of 6. So this would be 1 out of 12. Got a bag of marbles. There's 3 red, 2 blue, and 4 green in there. What's the probability of getting a red and then a blue? And we're going to say that this is without replacement. So this is going to be dependent. So probability of red times the probability of blue given. I've already got a red marble, didn't put it back. And I've got 3 red out of 9 marbles. Take that marble out, I have 2 blues out of 8 marbles. So that'll give me 1 over 12. A red and then a red, so the probability of getting the first red times the probability of getting the second red given that I've got the first red. Okay, getting a red would be 3 over 9. Okay, second red. Okay, I took 1 red out, so I have 2 reds left. I took 1 red out, so I have 8 marbles left. So this would be 1 out of 12. Okay, probability of getting a blue and then a blue and then a blue. So the probability of getting the first blue would be 2 over 9. I take that one out. Then I have 1 blue left over 8. Take that blue out. I have no more blue over 7. So this 0 right here is going to wipe everything out. And it's going to give you a big fat 0. Because if you only got 2 blue in there, how are you going to reach in and get a blue and then a blue and then another blue? You can't. It's impossible. You can't reach in and get 3 blues when you only have 2 blues within your jar or your bag of marbles. Okay, what's the probability of rolling a 1 and then a 2 and then a 3 and then a 4? Now, if it's dice, this roll right here, the first roll is not going to affect the second. Second's not going to affect the third. Third's not going to affect the fourth. So all these are going to be independent. So I'm looking for the probability of rolling a 1 times the probability of rolling a 2 times the probability of rolling a 3 times the probability of rolling a 4. All of these would be 1 over 6 or 1 over 6 raised to 4.